Okay, so we are going to start talking about calculus now. Um, and the basis for calculus starts with this relationship between the position of an object and the velocity of that object. So this is how these ideas arose, and then we generalized them, and now we can use them in a variety of different contexts. But just to give us an idea, the main example that you can think of is velocity and position. So velocity is a rate of change. And to compute velocity, what we do is we take the change in position of an object and we divide it by the time elapsed. Okay. But there are really two types of velocity we might be talking about. The first is average velocity. And the second is instantaneous velocity. Okay. And to give you an idea of what those two things might be, so if I were speaking about average velocity, I might say I averaged 50 miles per hour for the first hour of my road trip. Okay, so when I say a sentence like that, I am talking about the average velocity, right? And it occurred over a time period, right? For instantaneous velocity, I might say something like, I am driving at 65 miles per hour. Okay. So the difference between the two of these is that in this first case, this happens over a period of time. Or in terms of functions, this is over an interval. Right? And instantaneous velocity happens at a single point in time. So average velocity is not hard to compute. And basically, we just use this formula that I gave right here. So the change in position over time elapsed. So if you wanted to know your average speed over the first hour of your road trip, you would just take the distance that you've traveled and divide it by that 1 hour, right? For instantaneous velocity, it is not so clear how we would compute this or how it is computed in general. So how do we compute this? Since we have that this is happening at a single point in time, that means the time elapsed in this equation up here is actually 0, which would mean we'd be dividing by 0, which is one of those things that we want to avoid, right? So that's going to be a problem in our definition up here. So actually, I kind of lied to you when I wrote this down. This is actually only valid for the average velocity. Okay? And if we want to know the instantaneous velocity, we have to do something different. Okay. So I'm going to tell you how we would go about doing that, but we don't yet have the tools to actually do some computations. But the idea is that so we're talking about a single point in time. We really have two issues. We have that there's 0 time elapsed, and if we're talking about a single point in time, is there any change in position either? So you can't really change a position over a 0 amount of time, right? So the answer to this problem, so this question right here, this like here. So our answer would be to approximate the instantaneous velocity by computing the average velocity, which we know how to compute, write this out, average velocity, and we'll do this over smaller and smaller intervals. Okay, so this is sort of the idea, but this really doesn't get you all the way there to the exact answer of the instantaneous velocity. And so what we will do is then pass to the limit. And if you don't understand exactly what this means right now, it should become clear over the next few sections. Okay, and really this is the main idea of calculus. So let me just so the idea is that we approximate something and then pass to the limit. And by passing to the limit, we get an exact answer or the exact solution that we're looking for. So you see that this notion of limit is going to be very important. So we're going to spend the next few sections talking about that. And it can be a little bit difficult conceptually if this is like your first time seeing it. But if you want to really understand calculus, this is what you want to understand. Like, what is a limit? What does it mean intuitively? That kind of thing. Because we'll be using these for the rest of the semester.